Good morning, majors. We are doing day 8 of the circle. So we have one more day after this, and you guys are all done with circles. Anyway, arcs and angles measure is what we're going to be doing today. And there are a couple of formulas that we are going over. But once you see the formula, then the rest is just going to be application part. So the first formula we're going to go over is, if you guys just to quickly review, we talked about how whenever you have a circle, right, and we have a central angle, we talked about that. And then we also talk about when we have a circle and inscribed angle, right? So if this is x, this would also be x. So let me get a better pen so that I can, this would also be x. If this is x, this angle would be half of the x, right? It's going to be half x. That means it's going to be half. When we pull it all the way to the inscribed angle, which is on an angle created on the circle, it will be half. So if this is 50, this would be 25. That's what we discussed about. Central angle will be the same, but inscribed angle is half. Now we are going to have an intersection of two chords or two secants and creating an angle inside. It's not at the center, it's not on the circle, but if it is inside, so to is what we're applying here. If two secants or chords intersecting inside a circle, then the measure of the angle formed is equal to half of the sum, that's the keyword, of the measure of the intercepted arc. So for the measure of angle 1 is half of the intercepted arc, which is BC and AD. So you add what BC and AD is and divide it by 2. The same thing for angle 2. The intercepted arc for angle 2 is AB and CD this way, right? So angle 2 would be 1/2 the measure of AB plus CD. So that's what we have to do to solve it. All right, so how do we apply? So let's go to do a couple of problems. Maybe we'll do the odd side, one side, and then we do in class the other side, okay? So for the first one, you're looking for this angle E here, okay? So we know angle E, AED, I guess, AED. I like when they name it with a number because it makes it easier. It's going to be half of the intercepted arc. What is intercepted by this chord? It's going to be 109 plus 45, right? So all we had to do is plug in this into our calculator. So I'll pull my calculators out. And then you just add 109 plus 49 and then divide it by 2. Most of you already have got the answer. 109 plus 45. The sum is 154 and then you go ahead and divide it by 2. 2, that would give you 77. Good job. So the measure of angle AED is 77. So once I know this is 77, so just remember the vertical angles are going to be congruent. So they're going to be the same. But if I'm looking for the other angle, I can see, remember, this is supplementary. So knowing this is 77, I can do 180 minus 77 to find this angle. So just remember, we can also do that. And then when they gave it to you in terms of 3 letters, make sure you know which angle they're talking about. Okay. So that you guys are not making a simple mistake, okay? So this one for number 3, YWX, YWX is what they're looking for. So I'm looking for this angle, right? But the angle that the arc I have is to solve for this angle here. I'll just use the yellow. This is what, if I add and divided by 2, that is the yellow one is what I will be able to find. So I have two options. I can either do uh, find the yellow angles and then subtract it from 180. I think that would be the best way. Or you could add this two up, which is 43, and 81, subtracted from 360, which gives you the sum of the leftover arc, and then you divide it by 2. So both ways would work, but I think let's just stick with the rule. You know what? I will label this as angle 1. Okay, so I'm solving for angle 1. So I'll just do 1 half 43 plus 81, right? So that would give me what that measure is, and then of course I have to do uh, subtract it from 180. 43 plus 81, that gives you 124, and then you go ahead and divide it by 2. It gives you 62. So 62 is angle 1, but I'm looking for the angle next to it, so I have to do 180 minus 62 because they are linear pairs. 118. So 118. So this gives you 62. So angle 1 is 62. And I'm looking for this angle here, which is 180 minus 62, which is 118. All right, so let's go get done number 5. So I'll do the even number in class, but if you guys want to go ahead and practice, you guys can do that too. So in this case, the question is, what is CDE? What is CDE? What is this side? Right? So we still can apply the rule. So the angle, which is this angle here, 128 equals half of the two arcs. So I'm going to label this as my x. Okay? 73 plus x. So the easy way is to get rid of this fraction. So I'll multiply this by 2. So I'll take 128. Where's my calculator? 128 and times it by 2. So 128 times it by 2, right? That would give me 256. Then after I get to 56, I have to still get rid of the 73. So 256 is what I got, minus 73, right? And then that would give you 183. Okay? So when I did this, I got 256, right? Equals 73 plus x. So I have to do minus 73 minus 73. I found x to be 183. Okay? All right. That's what we got to do. So we'll do the even number in class. All right. So the next one is on the circle. So this one is similar to what we did earlier, the inscribed angle last class. But sometimes, what if it's a tangent line? So this is if a secant and a tangent intersect at a point of the tangency, then the measure of each angle formed is equal to half of the measure. So since the angle is being created on the circle, that all we do is half of the arc. And we went over this when we did inscribed angle. So since we're talking about all the angles, we just wanted to add this into it. So even if it looks like one of the line is tangent, it looks like it's outside, still you do half of the intercepted arc. So to find angle A, to find angle 1, you have to half AB. But if you want to find angle 2, you have to have BCA, which is this side. So that's what this part did, right? DEG is half of 308, which is 154, and DBC is this piece, which I didn't know was initially 168, so I have to do 360 minus 192 to get 168. So once you get 168, you have it to find it. And that's another thing you guys have to do. If it's not given, then you have to find it. So if this is 151, the arc will be double. 2 times 151, it would give you 302. All right, the third type of angle is being created outside. Outside can be two secant intersecting like this, or I might have a secant and a tangent intersecting like this, or just two tangent intersecting it like this. The good thing is all three of them, even if it's three different type of angle being created, the formula applies the same. Outside angle is half of big arc minus little arc. So we don't want a negative number. So we always take CE minus. Remember earlier it was plus. If it's inside, you add. If it's outside, you subtract. That's the rule you have to remember. And BD is going to be the smaller one. So big minus small, and you divide it by 2. The same thing, big minus small, you divide it by 2. So don't make sure you're not getting a negative number. If you do, then you're subtracting it wrong. So make sure you always do bigger minus small. Okay, so this is the formula we're going to follow. But as you can see, all of them is the same. Big arc minus little arc divided by 2. Okay, and we usually write it down to remember. If if it's exterior angle, we'll just say exterior angle is, we said it's 1/2. So both have big arc, right? Big arc minus little arc. So red says bark minus lark divided by 2. Bark at the lark. If it dog is outside, it would bark at the lark. So this is a different method people use to remember which two numbers we're going to be subtracting. Okay, so let's do a couple of problems to get this done. All right, number 10. I guess I'll do the even number now. All right, for this part, I'm looking for KLM. So since this is an angle, I'll just write it as angle L equals 1/2. Big arc is 140, right? Minus 66. That's it. So all you have to do is pull your calculator out, and you can even do, I know I've been doing it, so I can do alpha y equals to fraction 1. I know it'll probably take longer to do it this way because I have to press the right key. 140 minus 66. I see if it got minus 66, close parentheses. So when you do half of the big arc minus little arc, you get 37. That makes angle L, or KLM, angle KLM is 37, right? 37 degree. That is the answer. All right, so when we have problem like this, so let me do 11 because it's kind of next to it. So 11 is, I know B is going to be half of big arc minus little arc, but I don't have the measure of the big arc, right? As you can see, I don't have this piece. I don't have this piece. But I know this is 88 and this is 62. So you gotta find this first. So I have to do 360. Well, those are the things that becomes a little bit trickier when everything is not given. You kind of have to uh, did I take it out? You have to find it, okay, and then use that piece to be able to put it in a formula. So if it's not, you can't just say, oh, I don't know what AD is, but we know what a circle is and how to find it. So make sure you guys are paying attention to that one too. So I'll do 360 minus 62 minus 88, which is 210, right? So this is 210. This is 210. Okay, so now all I have to do is angle B is half of 210 minus 62, right? Because it's the big arc minus little arc. So once you solve it, that's what you have to do. Okay, so make sure you guys pay attention to everything. So the same thing with this one. So this I knew, so this was like you can say, how would you know this one? So I knew AB is the diameter, right? So the whole thing is half of a circle, which is 180. So if you do 180 minus those two numbers, it gives you this piece, which is BD first. And then you do big arc minus little arc to find C. So this would be the last one I will do for this problem, because this also is another kind of challenging question. So a circle is 360. I know the big arc PSR is 313, but I don't know what the other one is, right? So what I can do is do 360 minus 360 minus 313, which gives you 47. So this piece here is 47. So now angle Q is half, don't forget the half, 313 minus 47. And then you just plug it in, right? This is it, guys. We will finish the rest of the package next.